All right, so let's use Newton's method to approximate another function. This is a simple second-degree polynomial here, x squared minus 3x, and we are going to be approximating this using a given value, x1 of 2. All right, so if you remember from my earlier video, if you haven't seen it, probably a good idea to do that if you're shaky on the foundations for Newton's method. That it explains exactly what Newton's method is and what the usefulness is and where we get this equation from. So the equation that we're going to use to approximate this value is xi plus 1 equals xi minus this entire rational over here, f of xi over f prime of xi. And so what do we need to do first? Well, I think a good idea is to go ahead and figure out what f prime of this original function is, so we don't have to worry about doing that in the middle of our other work and break continuity there. So let's go ahead and figure out what f prime of all of this is. So to do that, we're just going to say x squared minus 3x prime. Well, this is just equal to, we're going to use the sum, not the sum rule, the difference rule, which is just derivative minus the other derivative. So the derivative of x squared is just 2x, and the derivative of 3x is just negative 3. So x squared minus 3x prime is 2x minus 3. So we have this, and we can just keep that in our arsenal over here and pick it up later when we need it. This is f prime of x. Okay, cool. Next step. Let's go ahead and start writing out our equation. Xi plus 1, that just means the last x1 you were given, x2, x3, x4, the last x you were given to try plus 1. So x1 was the one we were given, so we're going to say x2 here. So bad marker. All right. x2 equals xi. So let's just go ahead and put parentheses. It won't save you time, but it will prevent mistakes for wherever we're going to see xi. Minus this entire rational here, f of xi. So just f is just referring to our original equation, so we'll put parentheses everywhere we see an x and then go substitute in xi, or 2 for that, in a second. So we have parentheses squared minus 3 parentheses over the prime, f prime of xi, which we figured out a minute ago is 2x minus 3. So 2 parentheses minus 3. All right, now let's go and write in our values here. So 2, 2, 2, 2, cool. All right, what does this equal? We have 2 minus all of this jazz here. So 2 minus 2 squared is just 4 minus 3 times 2, which is 6. So we have 4 minus 6 on the top. 2 times 2 is just 4 minus 3. So we have 4 minus 3 on the bottom. So we'll continue this here. x2 equals 2 minus 4 minus 6 is negative 2. 4 minus 3 is just 1. So 2 minus negative 2 over 1, or 2 minus negative 2. When we have a number minus a negative number, we can just change the sign. So all this is really x2 equals 4. 2 plus 2. So we have our x2, which is 4, and we can go and plug that in. So let's erase some of this work now that we have f prime of x over here, which we needed, and now we have our x2. So let's go ahead and write that down. x2 equals 4, which will give us a little bit more room to work. All right. Now we're just going to evaluate up to x3 here. That's going to be a close enough approximation for the purposes and length constraints of this video. So this will be our last run through here. So we did x2 last time. Now we need to do x3. So that's going to signify this part right here, just becoming x2 plus 1, or x3. x3 equals xi parentheses minus the rational again, f parentheses squared minus 3 parentheses over the prime, 2 parentheses minus 3. Let's go ahead and write in our values. We know that it's 4, so 4 minus 4, 4, 4. All right, let's work this out. x3 is equal to 4 minus all of this jazz. What is that? Well, 4 squared, just 16. Minus 3 times 4, which is 12, so we have 16 minus 12. On the bottom, 2 times 4 is just 8. Minus 3, so we have 8 minus 3. So x3 equals 4 minus 16 minus 12, which is just going to be 4 minus 3, which is going to be 5. So we have 4 over 1 minus 4 over 5. We're not going to worry about doing a bunch of common denominator stuff. Just put this in your calculator, and you're going to come out that all of this, or x3, is equal to 8 over 3. So that is the entirety of what we need to do. A little quick recap here. We're using Newton's method to evaluate this equation, approximate its value at a point f of x equals x squared minus 3x with a given initial x1 of 2. We put it into our Newton's method equation, as explained in the previous video, to find x2, which was 4. And then we repeated the process again to find x3, which was just 8 over 3. So as you can see, our values are getting closer and closer each time to what the actual value of that point is, and we're good.